Hello, everybody, and welcome to April virtual meetup for the AWS user group Aotearoa. My name is Chris Watson. I am the president of the group, and I will be your MC today. Now, it'll be great if somebody who is on YouTube would be able to just say hello, and just to confirm that you can hear me, you can see me, and that we can see your YouTube comments as well. So Andrew Frazer has done so, who's also presenting today, and so we have an infinite loop, and we have another person. Thank you, everyone can hear us. Okay, anyhow, welcome very much. Welcome to today. So our agenda today is basically welcome. We'll say thanks to our sponsors. We're going to give a general update on the group as well, and then we'll go to our speakers, being Terence, Tal, and Andrew, and then we'll do a wrap up. So, oops, there's a typo here. Sorry, Kira, and welcome. My apologies. I took last set of slides and modified them, and I forgot to modify this slide. So this is not our first virtual meetup of this calendar year. It was our second. Still hope you're all doing well and everything's good with you. Okay, just start with our sponsorship. So we are a community-led and user-focused group. We're inclusive of everybody, but we are grateful to have our sponsorship continuing from Datacom and from Consigna, of which we need their sponsorship to help pay for our streaming services, Meetup.com, etc. as well, and just be rest assured that all of the money we receive goes back into the community in helping to make these events possible. Just a quick general update as to where the group is at and what we've been doing. As always, we need speakers, both virtual and physical. So our next virtual meetup we yet to determine, but please reach out to us if you'd like to speak. And also we need speakers for when we do Auckland and Wellington physical meetups. Other news is our website is being redesigned. Now we've been a little bit slow, sorry. So I was kind of hoping we'll be able to actually announce it going live by now, but we haven't. But we are still working on that, and we'll be launching that, and that'll be included in that will be a full Te Reo translation. Some exciting news. So there's an Auckland AWS user group which has been run by Gathika mainly out of the AC3 building for quite a few years now. Now we've been affiliated with them for a little while, and we've just recently formally brought the Auckland group into the Aotearoa user group. So welcome Gathika and the rest of the Auckland group into the fold. So in terms of physical meetups, we have two coming up next week. One is in Wellington, which is basically a social catch-up. Wellington has not done a physical meetup of any sort since August last year, so we're really, really keen to start to bring that back. And so next week, we're just doing a low-key social catch-up next Tuesday. It's not an educational one, it's very much just a social catch-up. And on next Thursday, the 5th of May in Auckland, there is a physical meetup happening, which is a full-on sort of meetup event with speakers, etc. Please go to the Wellington and to the Auckland meetup pages for details as to location, etc., and to sign up. And we're getting near the end of April, and we're a bit late on our April newsletter. Sorry, we'll be looking to get that out in the next few days. So speakers today, we have 3 people speaking. We have Terence White of Clearpoint. He's going to be talking about recent AWS highlights. We have Tao Lin, also of Clearpoint, talking about processing IoT data from aircraft via Lambda and Step Functions. And last, we have Andrew Frazer, who's a contracting engineer. He's going to talk about Twisted Pipelines, a journey with Python, CDK, and Projen. So it would be great if we can bring Terence up into stage. Hey, Terence, how are you doing?
Hi, everybody. I'm going to just give you a quick rundown of some of the highlights that have popped on the AWS new announcements feed over the last month or since our last actual broadcast. I've picked 12. As you know, AWS releases stuff all the time. Please go and either check out the top link, which is the link to the new announcements page directly, or if you have an RSS feeder, or if you're using Slack, which has a built-in RSS reader, go and subscribe to the new announcements feature page over there, because there's no way that I can cover everything in the small amount of time that we've got allocated to us. The first big thing that got announced, I think everybody would think that this was really one of the top items of the month, is that Lambda functions can now be called directly from HTTPS URLs. You do not have to put something in front of them like an API gateway or an application load balancer. This is something that many years ago I wished was around when I started playing around with building web pages and having them call Lambda functions to do some backend processing. Ended up having to grab API gateway, put it in, and API gateway is great if you need an API gateway that does a lot of heavy things in front of it. If you just want to call your Lambda functions, then you now have an option of going directly to the Lambda functions URL, and this can be secured. This is highly available and scalable, so it's kind of like putting an application load balancer in front of it, but you don't have to pay for an application load balancer, and you don't have to pay for API gateway. The costs of calling this through the HTTPS endpoint is included in your Lambda invocation time. And I'm pretty sure a lot of people have already started playing with this, even though it's only been out for a couple of weeks. It makes creating microservices out of Lambdas very easily, and testing and development work very easy for those sort of things as well. Next big announcement for those who still use a traditional database at the back end, traditional RDBMS, Aurora Serverless version 2 is now GA, is now available for use, and is available in Sydney. So everybody should be familiar with the whole concept of Amazon Aurora, which provides you with a MySQL and Postgres compatible database. Yeah, have two options there, but it does it in a completely different way from a traditional MySQL server, Postgres server, where you have a storage layer and then you have your compute layer above that. Some of the problems with this were people would need to scale an Aurora instance for an anticipated peak demand, so you'd end up allocating quite a lot of compute resource to your production environments, because, hey man, one day someone's going to come and hit us hard, and we need to be able to cover for that. But now with Aurora Serverless v2, it's a little bit more like DynamoDB, where serverless, where it can scale up, and apparently it can scale up pretty quickly, so you don't need to pre-allocate capacity. And also, it apparently scales down as well. You only pay for the compute that it's actually using, not a provisioned compute for it. And some people might say, yeah, this was available. There was a serverless version 1. I don't think many people ended up using the serverless version 1. There were a lot of issues with it, and the times that it spent doing the scaling up and scaling down were quite problematic and quite long. This one is apparently instant on, instant off type of thing. So I think people who have considered Aurora but found it too expensive in the past will be looking at this one. It's also kind of good that you can now have Aurora for your non-production instances as well, which typically you might not have done because of the cost associated with it. Because if your development work isn't going on 24/7, you don't pay 24/7 for your database to be up. You're only paying when your developers are actually using it. In a similar vein, SageMaker serverless inference is now available. So for those people who use SageMaker, SageMaker is Amazon's machine learning tool that allows you to do a lot of machine learning in an easy-to-use way. In the past, once you had a machine learning model, you would need to deploy it into some containers and provide the compute capacity for that. You now have the ability to tell SageMaker, hey, just load this model and provide me with an endpoint, and it will handle the compute underneath. Now, it's not going to scale as rapidly as the Aurora Serverless version 2 did. And if you have a big model, you might have a bit of a problem with your cold starts on this. But it is, once again, one of those automatic scale up, scale down, and you don't pay if you're not using it. You don't have to maintain the underlying compute either. So if you're a machine learning person using SageMaker, this will be something that you want to have a look at. And for those people who do a lot of graphics development on the web, you don't want to build up a graphics machine in your own offices because, hey, GPUs are expensive and hard to find nowadays. Amazon Workspaces has launched 2 new options for you. What we have here is a slightly smaller option with 16 gigs of RAM and an NVIDIA TU104 Turing GPU in it. It has local NVMe SSD instance store for if you need to download some files and access them quite rapidly. And it has Windows available on it, or you can bring your own Windows licenses. Apparently, these are only available for Windows options here. And if you need a little bit more oomph, you can jump across to the Pro version of this instance type. This has 16 virtual CPUs on it and a lot more extra RAM and another 100 gigs of SSD instance store. So graphics professionals who want to run Amazon Workspaces now have some more options that they can take a look at and play with. Those prices that are on over here are in US dollars. So if you're in New Zealand, times them by about 1.5 to give you an approximation of what it would be if you were playing around with it over here. And then a whole bunch of other things that are kind of smaller, but also quite interesting. The people who are building multi-AZ solutions will be happy to know that if you were using a transit gateway, or if you had private link, or for some reason the Amazon client VPN, the data transfer costs between availability zones has gone. It now costs you nothing to send data from one AZ to another AZ. That's pretty cool. I know a lot of people are building things in the cloud that use transit gateways and send the data backwards and forwards. RDS now has the ability to have multi-AZ databases on outposts. And this will be of interest to those people who are really wanting to use RDS so that they remove all the problems with having to maintain their own databases, but also have data residency requirements that outposts can meet. So you want to pop it in your own data centers. You don't want to wait another couple of months or a year for the local zone or for the actual region to appear in Auckland. Then you can now use the multi-AZ option inside outposts, inside RDS. And this is something that I actually thought AWS had for ages, and I'm kind of disappointed when they announced it that they didn't. But it's a really cool thing. It's EC2 instances, when they have underlying hardware issues, will now recover themselves and will restart on another server. And the private IP addresses, the elastic IP addresses, the EBS disks will all be moved across to the other server, and it'll automatically restart. And that's now an automatic feature inside EC2. It's a tiny little thing, but it's something that really makes some people's lives a lot easier. Not much point in coming in the morning and seeing your servers failed and you're going to have to hit the restart button yourself. FSX for OpenZFS is generally available for those people who want to play around with FSX. I'm a big fan of ZFS myself, having worked with it back in the old Sun Solaris days. And it's nice to see that this is now available inside the cloud for playing around with. And in a similar vein, we've got FSX for Lustre, which has been moved from running on x86 servers to Graviton 2 servers, and as a result has basically 5 times the throughput and apparently 60% cheaper. So that'll be nice. The AWS well-architected framework was updated recently to include a 6th pillar over and above the standard ones of sustainability. And this is for the people who build services and products inside the cloud. You are now encouraged to build this in a sustainable way where you try not to use more energy than what you need for it. In line with that well-architectured framework update, the well-architectured tool, which is an AWS service that allows you to take your application or service, put it through the tool, which asks a bunch of questions, and you get a score rating how well you're doing on the well-architected framework. The tool has been updated to now include this new sustainability pillar. And for people who are interested in their carbon footprint, for people who are interested in running the most sustainable options, have a look at this. And if you need any help with filling in the questions on this, please reach out to your AWS account team or to your AWS support vendor. For those people who use Fargate, hooray! Apparently, some tweaks have been made, details undisclosed, and Fargate will now scale up 16 times faster than it did in December last year. So if you're starting up a service or a bunch of tasks, you can now grow this to a larger number a lot faster than what you could have done last year. So those people who are heavily reliant on Fargate to run their containers will be benefiting from this. And something that I think those who have multi-account strategies have been waiting for a while, the organizations has now finally gotten the ability to close child accounts from the master account. If you go and play around with organizations, you go and create a whole bunch of AWS accounts. In the past, if you've wanted to close those, you would have had to log into them as the root user and then, tick 7 or 8 checkboxes saying, yes, I'm sure, yes, I'm really sure, I'm absolutely sure, and then you close it. Now you can do it from the master account without having to log into the child account. And that's a tiny little thing, but I think it's really going to make some people's lives a lot happier. So those are my top 12 announcements since the last gather that we've had. I'm sure there's a lot more that other people have been interested in, but I can only do a couple of them because now I have to hand back over to Chris.
Hey, thank you, Terence. That was fantastic. Yeah, I'll have to go read through them as well. It is always hard to keep up to date with all the announcements because there's normally a ton. And some of them are very interesting, some aren't too relevant, but that was awesome. Thank you heaps. Okay, I would like to bring Tal onto stage if we can. So Tal's from Clearpoint, and he's going to talk to us about processing IoT data from aircraft via Lambda and Step Functions. And hey, Tal, how are you doing?
Thank you.
Cool, I can hear you fine. If we can bring up your screen as well, it'll be really good.
Yeah, let me share my screen.
Okay.
See my screen now?
I think we need, yep, cool, okay, that's awesome. Okay, I'll hand it over to you and I'll pop off backstage. Or yours, Tal.
Okay. Hello, everyone. My name is Tal. I'm the lead engineer, SI engineer in the Clearpoint. But today, I'm not talking about DevOps. I'm talking about how processing IoT data from the aircraft to render it as a 3D replay using step function and Lambda. So before I start that, I want to talk about the background about the company and why we're doing that. So the next slide coming up. So the company I'm talking about is called Spider Checks. So maybe some of you heard about this company. This company is an aircraft flight checking SaaS company. It's not brand new, so they are founded in 2007. So that means they already existing in, okay, I mean 15 years. So, but they have their own hardware. So if you see that in here, that's the hardware they manufacture, they design manufacture. That is called Spider. So the Spider is a device to put on the aircraft. We talk about the aircraft is the customer. The target market is we call general aviation. So this customer is the aircraft, small 5 to 10 seats or helicopters. We don't talk about the big airline aircraft. Okay, so because they have $1 million, they have the device to check these things. But this small aircraft, they just like your truck, your car. So it's a very low budget. So this Spider only sell, I think, about $1,000 US. So to do the tracking for safety. So that's what the company doing. So customer actually across the world. So I think biggest customer, the market is US, but also in South America and Africa, Europe, all across the world. Okay? So, and that means is when they're doing the tracking days, how can we get more from the data? So that's why we develop the new device called Spider X. That's make the company can from just a flight tracking to a data monitor platform company. So that's what we're doing. Okay, so that's the background. And the next, oops, sorry, so quick. So this one is about how the whole thing works, the high-level architect. So basically, you can see the aircraft. They have a Spider X and installed on the aircraft. And then that actually is IoT device. So they're using the MQTT protocol. So MQTT is a very lightweight the protocol and can transfer the data very, very quick to the network. So actually, we're just using the mobile network 3G or 4G and then send the data to the AWS. So there's IoT core, AWS IoT core. And AWS IoT and core engine, you can define the rule based on the rule, based on the topic, and then you can using to trigger Lambda and then to save data to the S3 bucket. So remember, this data actually, because we want to get the data as small as possible, that's not like a standard JSON data, XML data. Actually, this is a binary data format. So, and then the data pipeline, we do all the metric. That's what the step function and the most Lambda doing here. I will talk that later for the more detail about this one. And after that, we process the data, become the flight attitude data. So the front end, and then we save that to the database. It's done with DB, and then here's quite standard. So the front end just JavaScript add, and then get the data from the API, and then read the data and run the data using a 3D player to just play the data to the customer. So that's the whole high architecture there. So you can see here, so we're using AWS IoT to actually transfer the data from the aircraft, from SpiderX to the cloud. So and then process that. So that's the data, how we get the data working. And after that, we talk about here is how the data pipeline working. This we call it serverless data pipeline because we don't have any server. Okay, so everything we're using is serverless. So, and there's some challenge there. So what the data we got, the binary data, what is inside? So this data is some sensor data from the SpiderX device. So you can be here. So basically, maybe you ask, okay, why I need to transform the data from this sensor to become the active data to let them to the free data plane? Why you just direct the SpiderX to give the right data for us? That is because the cost. Okay, if you have a device, you can get all the data, and what you want Azure Direct can play on the free play data very expensive device. But this one only a $1,000 device. So why we need to do so many things there? So what the magic happen is when the data we go to save to the file to the S3, and S3 just trigger a SS event, and then add the Lambda to process this data. Remember, this message, this data is the file very small. So we talk about every file only store 1 to 5 seconds data. Okay, so every file. So you think about that. A file maybe have a 1 hour, 2 hour file. That's how many files? 1,000, 2,000. So every file trigger a Lambda. Okay, and then we transform this data, decode them, become a JSON file. After that, and we trigger another JSON event. So trigger another SS event, and then to start a step function. Step function, what they do is we talk about every file from what we call files from takeoff to landing, we call one file. So we get all these files and then make sure they get there. We just and then process them. So how the change is there? Remember, when the file they process here, they come to the step function. This one or two function files for the one file, they are not on the order. That's first change we face. Okay, so how are we doing that? So the step function we're using step function to do the wait, to the retry, to the loop to make sure, and we wait the file in the right order before we can process them. That's the first thing. We rely on the step function to do that for us. You can do that by yourself, okay? But why you doing it by yourself? And you need to write a lot of code. Step function actually provide this mechanism for you. It's very powerful, and also you can check that very well. So the first thing you're doing. And the second thing is what happens if some data file corrupt? That's possible because remember that we transform this data from the device using mobile network to the AWS. So maybe the network is not very reliable. Mobile network is never you can say very 100% reliable. Sometimes we will mixing 1 or 2 files. So step function also to help us to actually catch this one. So actually our step function can tolerate 1 or 2 seconds missing, but we cannot tolerate more. So what we're doing here, you can see is that's why we need to make sure once the file be transformed, we need to do some data validation. Say, okay, this data is good enough. We can actually to generate the attitude. If they're too bad, we will not generate the attitude, the data attitude to show the file because actually your file become corrupt. So you don't want to do that. So step function also do that as well. So at the same time, that's why at the same time we can do some parallel step using step function to we actually use the GPS data from the sensor to go to the Google aggregation API to get the some aggregation data to us to so that we can use that for the next for the other purpose. So both is in a parallel step. So that means we can do that together. And then after we finish this one, we save the data to the database. So that's what we're doing for process the whole things. So, and one more thing you think about that is one very key feature, and I found step function is very, very powerful. What is that called? It's called retry. So have you ever using retry? So I'm using a lot. What that means? Retry means is you can try catch in the step function, and then you can talk about put a setting called back of rate and interval seconds and mask append. What this means? That means, okay, first time I fell and I wait for a couple seconds, you set the threshold and then I do another retry. Only reach the maximum retry and then I exit step function. Why are you doing that? Remember, here again, the file coming, they might become not in the order, might become later. So our step function just wait there to keep waiting until your file coming, and I keep process that. But if you're too long, maybe your file 1 hour file, but after 3 hours, 5 hours, your date still not coming. So, and then I will stop. I will stop to try anymore, and then I try a couple times, and then I exit. So my step function finish. And maybe next time I pick up the same file if someday coming. So all this handled by step function. So I really suggest if you want to look at that, look at the try, catch, in step function. Actually, it's very powerful. We're using that all the time and solve a lot of problems for us. And now let's do a demo. So after the data coming, so and then we can add the data coming, and we translate this data become the attribute, and then we show that from the front end. So this is a different file from two customers. So I can show you a little bit. This file, the customer actually they're doing some petrol oil pipeline investigation. So they just fly over and they see the pipeline and see the pipe, see if there's any problem there. So this is American, I believe. This one is great state. If you know about Florida, American is at the end they call Florida Key. So it's a very beautiful place. But you can see actually there are a lot of mosquito there. This aircraft, they're doing the mosquito control, spray, and then aircraft to fly over about that. So that's a bit how to do it. So, okay, so this is the demo. It's very short, but you can go to YouTube and have a look at it if you want to look at that. So this is the data. And usually, the customer, we process data very quick. If the data can download from the SpiderX, the device, to the cloud, we can process that within 1 minute. We can actually process it, and then we can show the file on the fly. So even they're filing, we can show the file if we want to. So, but of course, if the network is good, if no network, we may delay. Okay, so why is it going? Go to the next one. Yes. Okay. So that is about the achievement. So because we're using serverless, we're using as much as AWS can offer to us. So we have a very small team, 6 to 7 member team from development to production to go live in 6 months. That's a big achievement. So the second, we don't have any dedicated DevOps engineer. So every team member, they write their code, they write their using GitHub Action to write IAC code and then deploy that every day, not every day, actually every week or a couple days a week, couple times a week, and then to keep deploying, continue to deliver to go to production. So because we're using service and it's a very high performance. I'll give you some numbers. Every day when we're upstairs, we process about 1,000 files, and we talk about 40,000 Lambda every day, about 2,000, 4,000 step function every day. So you think about that, that's a lot. And we process about 1,000 file hour every day. So because it's just only for SpiderX device. How much the cost? I can tell you it's less than $500 US dollar. So it's amazing how much we can process and how fast we can continue delivery, but at a very low cost. So we are very happy about the result. So thank you. That's all I got.
Hey, Tal, thanks heaps. Hey, just one small question. With that $500 US, is that per month?
Yes, US dollar.
Is that per month, though? You didn't state the time period.
Yeah. So I don't want to talk about is the step function and the Lambda, right? So I'm not talking about the S3 storage.
Okay.
Actually, S3, actually most expensive about it is the data storage.
Yeah.
So
That's cool. That was really good. Thank you. Now we had one question which got answered throughout the presentation, so we've got no questions for you right now. If anybody thinks of a question after Tal's gone back off stage, please ask it in YouTube, and we'll be able to get Tal to answer it later on. But that was fantastic, Tal. Thank you heaps. We'll take Tal off stage, and we'll bring on Andrew. Hey, Andrew.
Kia ora.
I can hear you fine. I'll leave it all up to you.
Hey everybody, great to be able to come and talk to you today. Today's not really a presentation about how to do something or even about some sort of technologies. It's more a little bit of a story about how I've had some problems and worked on finding some ways to go through there and using some technologies in some different ways. So really, this is a journey. If any of you like me, you probably will recognize some of these problems. There's always too much to do, and no matter what way you cut it and put it into Kanban boards or to-do lists or whatever, there's still too much to be done. There's not enough time to do it. And then when you look around, you go, heck, there's not enough people with any free time to be able to do it. And then we've got to do something about the endless problem that Amazon keeps releasing new features and new things which you've got to keep up with. So those are all a challenge. I just see the guys just asking me about my presentation. Is it the slides aren't? I've only got a couple more slides, guys, so don't stress too much. Yeah, so that's those are the problems I set out to challenge. And I've taken a bit of a journey. That's me reading the Amazon documentation. It's always a bit tricky when you're doing this virtually because you don't get the laugh from the audience. You all should be able to be doing a virtual laugh at me. So I imagine you are. And if I look at the comments on YouTube, they're delayed by about 30 seconds. So tough audience. Okay, so for me, the solution seems pretty simple. Is in order to be able to deal with too much to do, I should just do less things. I should do it in less time with less people, and then I should lock in and borrow knowledge from other people and use an entire community's knowledge, which is a thing to do. So what I'm trying to do is never do anything twice and just use it at the same time. To be honest, I didn't really know where this was going 2 or 3 years ago, and then one day it all kind of came together. And that's the last slide I have, and now it goes a bit scary and it goes a bit live. So just 1 second. So I'm primarily working on deploying infrastructure for a whole different set of projects that are all quite varying and different. But one of the things I guess it's the same all the time is that we want to be deploying things as infrastructure as code. We want to be deploying things in with a repository and version control and all those kind of things. So all that goodness, but it's actually quite a lot of work to set it up every time. So what would happen if we could just pass a few parameters to some magic black box and have it build us an entire CID project? The repositories, the pipeline, the whole shooting match. Just imagine if we could do that, which would be kind of curious if we could just do that. Well, turns out we can. And so our magic black box is just a automation document from Systems Manager. And in this automation document, it's just asking for a few parameters, so an account to deploy it to, a few little bits and pieces information, and I'm gonna create a project that's called AWS UG April, because we're in April. Execute that.
Hey, Andrew.
Yeah,
Just
don't
sorry,
you
sorry
love?
to bump in. You're probably not aware of this, but your screen is not possible to read right now. It's the resolution's just unreadable. So it's starting to get a bit better. He's had a little bit better. That's still not great. A little bit more. Sorry about this, everybody. It's obviously having a few problems. You can read. Yeah, that's mainly readable. I don't know why. It's your resolution's been fairly poor. I don't know if there's another screen you could use, maybe. I'm not sure.
Just 1 second. Let's see what we can do.
Yeah, sorry about this, everybody. Yeah. One option, Andrew, if you message me this slide, I could possibly send it, share it from my computer.
These aren't slides.
Oh, okay, right.
This is
Browser.
Are you able to see these?
We've just removed the slides from your screen from the put it backstage as well. So, that is better. If you just could you make it just a little bit bigger? It's definitely way better than it was.
Yeah, I was sharing it off my 4K monitor, which might be the problem.
Okay, I think we can read this. I think I think everyone's happy with that, so we'll go with that. Okay, I'll pop back off stage and you can carry on, Andrew.
I know what the problem was. It just signed me out while I was waiting. Yeah. So this black box that we're talking about is an systems management automation document, and it's just a matter of providing a couple of parameters, and some of these are pre-populated for me, but I'm going to just call this one AWS. This project is called AWS user group, and it's gone and done that. So the skill set required to create a new project is pretty much can use a web browser, log in, and put a valid thing in. Now, you are for sure going to want to know what's going on in the background. So what this is doing is there's a bit of a Rube Goldberg machine going on here. This automation document calls a Lambda. And the Lambda there is really just a bit of bubblegum to connect it to a code build job, because you can't as far as I know, I'll never say you can't do something, because when you say that, someone will put their hand up and say, here's a way to do it. So if you do know a way of connecting a automation document directly to a code build, let me know. But code build picks up these, gets these parameters that we passed in via a Lambda. And this Lambda will has now triggered a code build job. So if I'll just go and find the code build. So I'm just going to have to go down. Because I got the screen too big. Here's so that took a little bit longer than I hoped. So this this code build job is going to take about 8 minutes. So we're not going to watch it entirely. But what it's doing is this build's calling some really interesting software called Projen. Now, Projen is something that has kind of spun out of this Amazon CDK project. And if you can kind of guess out of its name, so it's a project generator. And at the end, I've got a URL, but it's a public, it's a open source bit of code. But basically, it'll do a whole entire project generation. So what's happening here is code build runs Projen. Projen takes the parameters that we supplied on the automation document and then a template that's that we built, and then it spins up and creates an entire CDK project, which is based on those templates. And then the last thing that code build does is it goes and synthesizes that CDK project that's been built on the fly, and then deploys it. And then part of that, so the synthesizing turns the CloudFormation of this, so the CDK project, which in my case has been written in Python, but with CDK you can write it in TypeScript or JavaScript or a few other bits and pieces, and that synthesizes into CloudFormation, and then that CloudFormation gets deployed. Now, part of our CloudFormation stack is actually making some API calls to an external Git repository. And so that's creating a Git repo. It will initialize it and will put up some code. So this thing's busy way doing its thing. And as I say, it will take. You can see in here that it's downloading packages and all those bits and pieces. So there's quite a lot going on there. And in fact, I think it's actually finished. Oh no, it hasn't finished. But because watching a code build job is just slightly boring. Give me 1 second, and I'm just switching screens. The joys of a live demonstration. Okay, and we'll just make that probably a little bit bigger to make it readable. Okay, and so what I can do now is that, so as I said before, I created one this morning. So I'm just going to clone this project that I made this morning, called Made This Morning. Okay, and so let's jump into that repo, and we'll actually see that there's not a lot in there because of the way that the repos are. We'll just check out the staging branch. Let's complain. It will want us to okay, and so what we've now got in here, so if I go into my project made this morning, what we'll see, let's close that, we'll see in here, sorry, it's a little bit hard to see on the screen, is an entire CDK project. So what you'll actually see in here is some basic, is a CDK app, and it's all driven around some configs which are built in YAML. So we actually have this project here. So we've got a project name, some configuration, and some other files. We're going to build a stack. Now, what's interesting is that our project, so you can see that we've got the repo there, but at the same time, if I go into see my pipelines, is that it stood up. This is a code pipeline, but this was all generated with CDK building this code pipeline. So you can see there it has a source which our repos end up in an S3 bucket. There's a build stage to do a synthesis, update pipeline, an example. Now, so what we've done here with essentially with just a couple of clicks is we've been able to create from that SSM automation document, we've able to stand up the pipeline, we've been able to stand up the repo. It's all been built in a consistent way so that anybody that within the team is building on these projects will be able to instantly understand how the project's laid out. Because like with many things, there's 1,000 options for how things can be done, some of them correctly, not many of them wrong, just many things that can be done better than other ways. So a lot of things will work. So we just have these, and you'll be able to see we have some code in here, very simple application here. That's just going to pass in a label and deploy a single output. So if I want to actually push this in, it's a pretty easy process, obviously. I'm going to maybe I'm just going to put in Let's pretend that this is a big project and this doesn't have some CDK outputs in it. We'll call this another label. And the value can be labeled as well. So we've made some projects to push that and deploy it is only a matter of, sorry, I'll just get rid of that. So I'm just going to and that's going to commit to the repo, and in a few minutes, well, it won't even really be a couple of minutes, it'll be and what you can see here is that this is now triggered the source. You can see it's just running now. It's being synthesized. So if we jump in there, we can see this. And this will take a couple of seconds. And so what we've created here is, and where this is be called Progenator for the want of a better thing. However, essentially what we've done is with a few clicks, you've got a whole project that's built out. So really, I'm not wanting to suggest that this is a particular way of building CI/CD processes, but it is a way that it can be done, and it's proved to be really effective. The one thing is setting up all these pipelines by hand. It takes quite a lot of time, and it's quite error prone. So you get consistency there. So that that when I go back to my slide to say about do less things, well, instead of me having to do all that things, I've let a machine do it. The next thing was do it in less time. When I used to do these by hand, it was probably a good solid hour's work to set up a basic pipeline, and then you'd find you'd miss pieces. I could have gone away and done that and be finished in 5 minutes. Had a cup of tea and come back a few minutes later and it's done. The other thing is that with using CDK and putting things in libraries and using the constructs that CDK provides, I don't need to have to necessarily be an expert in every one of those things. I just need to be able to understand the abstractions of that particular construct. So all those things are a big time saver. And this process, it started out in very small ways. I mean, it's grown and it's grown and it's grown. And at Contact Energy, where I've been working for the last year and a half or so, it's made quite a big difference to the way that things have been able to be deployed. So we can see it's just about finished. So it succeeded there. It's built its thing, and what it's going to go and do now is it's going to go and deploy it. So really, that's what I've got to share today. And just wondering if there's any questions.
Yeah. We don't seem to have any questions on there, but if anyone has, just please put them into the chat as soon as you can. Yeah, well done on getting a live demo to not crash. And yes,
it's always a little scary.
Yeah, there's always a bit of risk, and Yes, obviously we got the screen resolution sorted out, so our apologies to everyone watching for that small hiccup there. Okay, so I'll get everybody to come back on stage. If anybody's got any question for Andrew or Terence or Tao, if he's coming back, or not, as well. But okay, if anyone's okay, Tao, you're back. Okay, awesome. Okay, well, I don't think we're going to have any more questions. If someone does, please please get that through very, very soon. Otherwise, obviously a couple of things. So if you could just bring my screen on too as well, see if that'll be good. Thanks. So obviously, yeah, thanks to Terence, Tao, and Andrew for speaking today. Next virtual meetup date and location is TBC. As mentioned, next week we do have 2 physical meetups. One's a Wellington social catch-up on the Tuesday, and the other is a full-on Auckland meetup on the Thursday. Please go to the Wellington and Auckland meetup pages respectively for details on that. Apart from that, we're always after people to speak, anywhere from 5 minutes to 30 minutes, beginner to advanced on any part of AWS basically. We had Martin in the chat wanting to speak, which is fantastic. So Martin, just reach out to that link, the Slack link, and get in contact with us would be awesome. So it doesn't look like we have any questions. Okay. Anyhow, we'll wrap it up now. Thank you everybody for watching, and we hope you learned stuff and enjoyed the session. So thank you everybody, and goodbye.